All right. I'm going to give a couple minutes. I haven't gotten any confirmation that we should be starting yet. I don't know if there's people on the channel.
Hello, Nick. Can you hear me okay?
Yes, I can hear
you.
I can hear you, yeah.
Okay.
Would you recommend I start in a minute or two, or?
Yeah, you should start in a minute. I think it's at 1, right? Or yeah, I think you should be good now.
Okay. Great. Well, okay. Hello. Good afternoon. I'm sorry, I might have some outdoor noise on and off here. I'm going to be presenting about plug into JAX frameworks. And JAX is a machine learning library. So I'm going to try and give a very broad overview of what that's about. A little bit about me first. I'm Nick Doiron. I'm a software engineer. My background is usually like web development. So I'm just getting into software engineering and machine learning more recently. And I work on redistricting at Tufts University. Right. So intro for web developers like me. I'm not like downgrading web development, but that's just in case you have less experience with this. This is going to be my outline. So I'm going to explain things to web developers. Just a minute, I'm going to move inside. Or no, I'm actually okay. Okay. Okay, how does JAX fit in with other machine learning libraries that you might have heard of before, like PyTorch and TensorFlow? Why do machine learning researchers start liking JAX, even though it's brand new and doesn't have as much information yet? Frameworks that make JAX easier to use. And then I have some links, which I hope will be distributed with this talk somehow, about code and some interactive Jupyter notebooks. This is kind of a long time slot, so I put in some Q&A checkpoints throughout the talk where I'll tab over to look at the other Loud Swarm tab. All right. Yeah, as I was saying, I'm going to have multiple Q&A checkpoints where I'll go back to look at Loud Swarm to see if someone's asked a question there. Let me get back on track here. So yeah, as I'm a web developer coming into this, I know how to code, but I feel like AI and machine learning can sound intimidating, and I want to come into it in understandable parts. And there is more beyond what I'm presenting about it, but I want this talk to be something that can point people in the right direction. So let's start with a task. So this is a project that's on Kaggle, and there are thousands and thousands of flower photos in this project, and they're divided into 104 different types of flower. So this Kaggle challenge is, can you make some code that learns from the labeled photos and basically learns how to identify these 104 different types? And so this is a machine learning problem that is technically known as supervised learning because you're giving it some examples to train it. And it's also called image classification because basically you have images and there's 104 different classes you're dividing them into. So typically what happens is when you get a machine learning problem, you're going to get a training data set, which includes all these thousands of photos that are labeled, and a test data set, which is also labeled, but you keep it separate from the rest of your data so you can test if it's really working or just kind of copying off its own answer sheet, basically. Like you hold some out to be the actual test to see if it's working. And I know this talk is about JAX, but one thing that I do, especially when I'm just getting started with something, is I like to use this auto machine learning library called AutoKeras. So this is based on the Keras machine learning library. And really, you just kind of drop in a data set for this kind of supervised learning problem, and it'll do a lot of the work for you. So here I've loaded in all of those images in 192 pixel by 192 pixel by 3 channel RGB. Like it's a data set, it's turned into a bunch of a multi-dimensional array of numbers. And once I just put that into the image classifier class from AutoKeras, it'll start coming up with different architectures and different networks that it would use to solve an image classification problem. And then based on whether it works or not, it'll choose different architectures until it finds one that it feels like is going to be the most successful. So here you can see just a simple number of code that once I have that in training data processed, it can start learning from it. So what did it do though? Like it got to 84% accuracy, but what is it really doing in there? And how can I as a coder learn from what this AutoML tool is doing? So you're able to export the model into just a regular Keras model and look inside. And so each neural network during the neural network was built up of these different layers. So you can read them here. You know, it came in as 192 by 192 pixel image, went through some normalization, did this translation and flip, which it takes the image and makes some changes to it, like flipping it or moving it, resizing the image, and then it goes through something called ResNet 50, which I'll talk about in a minute. And then at the end, it goes through layers, which narrow it back down again to 104 different scores. And whichever one is the highest score will be, that's the class that it predicts this flower is. So if you can imagine there are two flowers that are very similar, the last layer isn't going to say 100% it's this one and 0% chance it's 100 anything else. They'll say like 99% this, 95% this, and then the rest of them in turn. So chances are then your accuracy is going to be really good if it can get very close to identifying the item that it is or something that's very close to it. Getting in more detail there, reason it's doing this image flip and translate steps in the beginning, those are a process called data augmentation. So you take the original image and you say, I want to have like 10 times as much training data, or what if the training data was all people looking to the left, and in real life there could be people looking to the left and to the right. So it's taking the original training data and making some changes so that we know that a variety of cases can be predicted and taken care of. Then ResNet is something interesting that just in general in machine learning, there's a large set of pre-trained neural networks where people have gone to work on very large data sets and trained these models and found they're really good at image classification, finding like the edges of images, finding faces in images. In text libraries, there's also a little bit of this as well. So ResNet is an example of a very large neural network where you start out with that and then you fine tune it to your actual problem. So when we were looking at these layers here, it gives us a hint of an image classification problem. You want to start with some data augmentation, some image augmentation steps, and then have ResNet there at the beginning of your training, and then train that up to be more accurate. So this is what I put as a question checkpoint, because I've just explained, what does a machine learning problem look like? And what is the problem that I'm looking at specifically right now, this example problem of the flowers challenge from Kaggle, turning that into, okay, we want to turn that into numbers and we want to build a neural network And AutoKeras has kind of built a sample neural network so we know what it should look like. I'm gonna peek and see if anyone's asked a question here. I don't see anything, so I'm gonna keep going. So this can only do so much. It's an automated machine learning library. So in a lot of cases, it's going to get us to a pretty good thing. Like of 104 different flowers, I don't think I would get 84% accuracy rate if you quiz me right now. So it's doing something. It's getting you somewhere. If it was random chance, it'd be less than 1%. Think about it that way. But what do we do if we want to get better results, or if there's a brand new problem that isn't just, labeled as image, that is something that's more complicated and isn't handled just by the auto ML libraries that are out there? So you're going to want to design your neural network programmatically. And there's a lot of different ways to do this. I'm just listing 4 of them here that you're probably familiar with 1 or 2 of these: PyTorch, TensorFlow, Keras, and Paddle. And if you're wondering why do people use these, is one more accurate than the other, one more advanced than the other? It's actually kind of more of like each one is associated with a company, where PyTorch is mostly maintained by Facebook, TensorFlow mostly maintained by Google, Paddle mostly maintained by Baidu, and then Keras is just really complicated, but also I really appreciate it, so I wanted to include it here. JAX is going to be something completely different. So it's been on GitHub less than 2 years. People have been talking about it for a while. At first, when I heard about it, they were just saying, "Oh, it's a replacement for NumPy." Right? And if you're familiar with NumPy, or if you're not, just basically it deals with, arrays or linear algebra or very small matrix operations. So I never thought of it like as being like a big machine learning library. But over time, and especially earlier this year, there are a lot of frameworks and libraries that have been released that are based on JAX, and there's a lot of interest in them. If you go look on Twitter, it's not super popular. It's not like at the level of PyTorch or TensorFlow for like actual projects, but I keep seeing these things in the Twitter world. They're talking about using it for building new types of neural networks, using it for research problems, using it for different projects, saying that they really like it. I especially like this point saying that it's useful for prototyping quickly. So what is good about, why would someone switch over when there's already something called NumPy that does NumPy stuff, and there's already something called TensorFlow that makes neural networks? Why would you want another library from Google to solve the same problem? Well, it's designed from the beginning to take care of specialized hardware. So if you know neural network training, if you're just running it on your laptop on a CPU, it's probably not going to get very far. You want to train it on specialized hardware like a GPU, or in Google's case, the TPU, that handle these kinds of matrix operations very quickly and efficiently. And it is possible to, for example, run PyTorch on a TPU, or different combinations like that. But in general, these other libraries had not been designed with this specialized hardware in mind. You kind of have to build some kind of carryover to get your code running there. And sometimes that's handled for you, but you're not natively interacting with the GPU or TPU in these other libraries. JAX is going to change that. And so you're writing Python, you're writing stuff like you would use to talk to NumPy and make a NumPy array with different types. And that's automatically handled for you and taken over to, it can even be on multiple GPUs or TPUs. I typically just run stuff on Colab, but I like knowing that the code that I'm working on and the code that I'm learning how to use could be run in a much larger machine learning research setting. So if you're kind of lost in this whole thing, I've made what I'm calling my zodiac diagram of where everything is. So there's like the TensorFlow family of items, there's the Keras family of items, there's the PyTorch family of libraries, and at the top you have stuff like auto PyTorch and auto Keras that I showed you earlier that are just very high level, drop in some data and start doing stuff. And then at the bottom of the chart are very low level things like CUDA, which talk directly to the GPU. And I'm not an advanced computer science researcher, so I don't want to talk to the hardware on that level. So I want to step up from that. And JAX is a step up from that. But even that is very simple. It's not going to come with the different objects and types of things that I'd expect in a neural network. So there needs to be something above this, above JAX, that helps me operate it and understand how to build neural networks with it, solving common neural network problems. And so this is where these new frameworks or libraries come in. This is a post from Miles Cranmer. He's saying that there's a ton of them. The ones that I've gotten a chance to look at now are Flax, Objax, Haiku, and Elegy. There are some others out there that I haven't heard as much about, so maybe they were kind of like lower level or they aren't used as much right now. There's just a very large variety of things that are all trying to solve the same problem of, I want to run JAX, but I don't want to like do that very tiny low level code. I want to have these like more direct interaction with building up and designing my neural networks like I would in like a PyTorch or TensorFlow, but still take advantage of all the benefits of having JAX be the foundation of what I'm doing. So let me double check if I have any questions here. I really wish it was all on Zoom so you could just paste it into the chat. Okay, let's keep going. So I mentioned earlier, these 4 particular frameworks seem to be popular. Flax is doing kind of a UI rewrite that they're calling Linen, which I was confused for a while until someone who knows stuff was able to tell me, oh, but the flax plant makes linen fabric. So it's connected. It's basically the same thing. Well, interestingly, the first 3 are all from teams inside of Google or DeepMind, which is associated with Google and Alphabet Megacorp. And Elegy is the only one of these that's sort of their own independent project. I think there are a few other people who've tried it independently, but Google just has more people that are more experienced with JAX right now. And I guess it's spreading within the Google company in terms of like new research projects. What I'd recommend is if you're doing machine learning projects and you say, I'd like to try one with JAX, they usually come with examples for MNIST, which is the handwritten digits, right? And ImageNet, which is like a huge challenge that has tons of different images, of many different types. So you can find an example of the code there and then adapt it to something that you're working on. And that's pretty much what I did when I had this flowers thing. I said, I'm going to take every ImageNet example and figure out how to get it to work on the TF record data set that I've downloaded from Kaggle with all the flower images in it, and make adjustments for like width and height, and there were several different adjustments they had to do. And I have notebooks that I'll link to at the end if you're more curious about that code part of it. I would also say ImageNet is really big. Like you're not going to be able to iterate very quickly on it. It won't download into the Colab notebook because there isn't enough space. It's also a possibility that you'll get a huge data set, ImageNet or something similar, and run it through your code, and then somewhere along the pipeline, it's going to break, and you're going to have to change your code and then start from the beginning. So first, the best advice I got when I started doing machine learning type projects was start with a very tiny data set, or even just one training sample, and make sure it goes through before you start adding gigabytes of data, and because otherwise you're not going to be able to iterate very quickly. For the specific problem, if you're doing image recognition, Fast AI has a project called ImageNet with a TE at the end. And that has a much smaller data set with only 10 different types of things. And then they also, in the same repo, have something called ImageWoof, which is just different types of dogs. So if you're looking for a small data set to get working with, these are two really good examples. Don't start with something huge and famous thinking that you're going to solve it and everyone's just start with something. I'm speaking from experience here. Start with something small and manageable when you're working on your project. Objax is one of these JAX libraries. And so you start by importing JAX and Objax. This is an example from the README before I get into like the actual example. And on README, it looks pretty simple. You just have some data and random data, and you're going to run it through a neural network linear layer, or run it through a neural network convolutional network. So these linear convolutional networks, whatever they are available in the Objax library, whereas JAX itself is so low level, it doesn't know anything about neural networks. It just, JAX is the foundation, Objax is adding in these specific calls, like the random library, and types, like the neural network layers. In a more complete project, you're going to want to input the data and make a prediction. And then when you compare the prediction to the reality, there's going to be a loss function there that's customized. And then the way that the weights are changed depends on your optimizer. So in the actual code here, first I'll start off with look, from Objax, you can import ResNet. Remember, if you remember way back to the AutoKeras library example, that ended up, looking at our problem and suggesting using ResNet 50. So that's how we're going to do it here too. We're going to import ResNet 50. The self.model code is saying, here it is, ResNet 50. And number of classes, 104 for the different flowers. The optimizer, there's a few different optimizers you can use. I don't know enough about the world of optimizers to tell you how you should be doing that, but you can see that Objax is to provide that for you. You're not writing like an optimizer or any of these things from scratch. And then computing the loss here is going to be done with this. It's your own loss function, and then this utility function for objects, the grab values. And then the final line of this that's interesting is objects up parallel. So that means that if you had like many GPUs or TPUs, or however you're doing this, you would be able to wrap your training function inside of a parallel structure and would be able to do this experiment. So basically, you're writing it as if you would do it on one machine and then wrapping it inside of this parallel system there. As I mentioned earlier, Objax comes with ResNet. Looking at their documentation, you can see it comes with some other sample projects as well, like VGG. And that just, like having a pre-trained architecture or common architecture that people use to solve image problems, it doesn't make sense to just start from scratch. It helps to have something like this that is in place. And then just if you click around the documentation, you'll see some really interesting things like it has this differential privacy package if you're into federated learning or privacy of training data in machine learning. This would be something really interesting to look into. As I mentioned earlier, optimizers. Our code was using the momentum optimizer. The atom optimizer is something that is more common, I think. So they have a few different optimizers that you can use, or you could, if you had this knowledge. Basically, these are all components that allow you to design your own neural network. Like in the beginning, we just let AutoKeras decide it for us, and we had no control over it. But we also had no control over fine tuning it or saying like in the beginning of the training, I want to do this, in the end of the training, you should be doing something different. These JAX, Objax, TensorFlow, PyTorch, they all exist for the same purpose of saying, I'm going to try and design something a little bit more specific. Yes, just a second. All right, here we go. Okay, so you have these different components that you can switch out and design your ideal neural network. Cool. Then the loss function, I was really trying to understand what is the loss function and why am I customizing it? And so I'll just show you the loss function that's in the Objax flowers, the image and example that I ended up adapting for my own problem. And you have the model that you're in the middle of training. Just send the images into it, and you're going to get back what they call logits. And here we're using Objax to calculate the loss or offset from what the actual answers were, and computing what is the number that represents this loss. And you might say, well, isn't this all the same? Like it's accurate or it's not accurate, or it said 50% accurate when it should have said 0% accurate. But there's some different examples that you might want to customize this. For example, if you're designing a self-driving car and it doesn't know the difference between a 40-mile-per-hour sign and a 50-mile-per-hour sign, that would be one kind of loss. Whereas something where it completely misses a stop sign, that would be a huge loss. And so you might want to weight that loss more differently. So here, I think that they just designed this so all the categories are equally weighted. Another example might be if you had a problem where you only had 90% of your data was in one category and 10% was another. You might want to increase the loss and messing up on the 10% so that it knows, oh, if I see one of these cases, I need to pay special attention to it. The model isn't that smart. It's not really knowing that that's what you're saying. But the loss function is an opportunity for you to correct for bias or issues that would be, extremely dangerous for your model not to know what's going on. Let's see, loading the data. So this, again, go back to when we had the AutoKeras example. It flipped the image. And here, in this example, we get the training data out of a TF record. So that's TensorFlow. And then you run the data augmentation function to randomly flip it left and right and shuffle the images and then divide it up into batches. You can't learn on all the images at once. So you set a batch size and then it continues on. And I think something that confused me about this is like, hey, I thought JAX is an alternative to TensorFlow. I thought Objax was an alternative to the TensorFlow family. Why am I still using TensorFlow? So what happens is you need to do that image data augmentation that we talked about earlier. And PyTorch and TensorFlow have this whole ecosystem already built up for you where you just say flip left or right, and it'll flip all of your images for you. Or you can divide it up into batches so you're not having all of the images in memory at the same time. Or so many different things that you can do with images or text data that come with having your data already being in a TF record. And that's why, I mean, in addition to the Google connection, that's why I think that so many of these examples still use TensorFlow as a utility. So your neural network is going to live in JAX and be trained and live on the GPU or TPU. But whatever it is that is accessing your data and doing all of this work before your neural network is trained, that is going to take advantage of all the tools that are in TensorFlow. I know I haven't seen questions on the platform before, but I want to just drop in and see if there's anything going on there. So just in the last couple of minutes, I showed you some examples of Objax and how they represent in the README, where it's just like, oh, you just have some layers that take data in and take data out with these particular these array shapes. And then a real life example where you want to customize the loss function and the optimizer to decide how your model learns stuff in the process. And then the actual code that's in the ImageNet example. And this is the same code that I used. In fact, if I've changed it a little, I might have changed it a little bit here, but it's essentially the same code in the ImageNet example, and I've used it in my own image example of the flowers. And then also when I got stuck, I would use the ImageNet TE at the end from Fast AI. So lots of different customization there. Cool. So DeepMind has another library called Haiku. I did not get very far with this, and one reason is that they do have like linear and other like layers that you can add to your network using Haiku, but virtually everything, including the loss function and optimizer, is left to JAX. Like it's basically just one step up away from working directly with JAX, because you can see here the ReLU and other things are taken directly from JAX rather than from Haiku. That makes sense. So yeah, that was Haiku. Flax, and then evolving into Linen. Flax, this is the information from the README. They have a lot of different options. They have the optimizers. They have more optimizers than we had seen with Objax, right? They have a lot of different examples, including sequence to sequence, which are more than some of the other libraries have. And it also has, as you saw, but it also has ResNet, which we know from earlier. ResNet is like a pre-trained, already tuned example, and then a transformer, which I'm not sure exactly how they use in this case. I know transformers is very common to use in an NLP context. So this could be a good starting point if you want to have one of those neural network building blocks in your own network. So here's the function that they have inside there. You are passed this node X, and then it goes through a graph convolutional network block, and then you apply other functions like this. So you keep applying it to the same nodes to build up like your layers in this definition. They also have a sequential structure that you can use to set this up, but you can see from here that this is a typical way that they're setting up their network with some different layers. Elegy, I mentioned when I proposed this talk, and I've been really excited about, one, because it's not part of the Google DeepMind world, and then two, because they are really trying to design it based on Keras. And so you have here, there's this example of a sequential thing where you define the layers as kind of an array, and you have flattened, linear, linear. And it has examples of convolutional 2D or 3D arrays. The problem here that I experienced was, the problem here that I experienced was just running the example code didn't work for me on Colab. And so I wanted to run the example and then upgrade it to work on image classification. And it wasn't running very well for me. So I think this is going to be really interesting once it's more stable. and it's good to have like another competitor to the other JAX frameworks out there. And I like the way that it's written. Like basically, none of these are guaranteed to be more accurate than the other. It's all about whether, just with PyTorch or TensorFlow, do you feel like this is the right community, or do you feel like this is the right structure for the code? And so if this code looks better than the other ones, then definitely keep watching this library. I have a bunch of notebooks that I wrote doing this. First, when I was doing ImageNet, and then second, when I was doing the flowers example. A lot of the code is just dealing with TF records because that's its own little bit of complicated thing. But I've created these different Colab examples so you can try them and that they work on problems outside of, outside of just the demos where they say, oh, import data set from data sets. You need to have an example where it's like, I have an actual like data set from Kaggle that isn't designed for this library or isn't built into this library. How can I work with it? So these are all examples. I hope there's some way that I can make this available to people who are watching this later. And yeah, so that's all I have to say about JAX at this point. I definitely want to keep working with it and learning more about it in terms of, I'd really like to get deeper into the code and know, which optimizer do I want to use for this problem? Or is there some way that I could try out a lot of them and see which one I like? That kind of, is there situations that I should, like basically a tutorial that talks me through why is there not just drop in the data and walk away? Like why isn't there, what are some good examples where you would want to customize the loss function? How do you know that's happening, and how do you change your design based on that? So I'm hopeful to continue in that, and I've definitely, it's kind of seems ridiculous to say to look at Twitter or to look at machine learning Reddit, but there are a lot of people having good conversations there, and that's how you find out about these like unofficial emerging libraries on GitHub. So these libraries are all open source. There's open source tools. Yeah, these are all open source. AutoKeras is open source. JAX is open source. The JAX libraries are open source. So you can get started. The question is like, what are these? What examples exist? How can we improve on them? And are people going to end up using them? Because you don't want to join a library and have it disappear on you, right? You don't want it to get kind of phased out. So I feel like we're going to find out in the next year or so, is JAX going to be kind of its own family of libraries along with these other ones, and what's going to be the best one to use, and how easy is it going to be? How easy is it going to be to use? So I'm hopeful that will move forward in the near future. And this is a lot of information, and it's kind of a long block of time. So I appreciate if you've kind of stuck with me through all of this. And definitely feel free to contact me on Twitter and GitHub. Tell me that I did everything wrong. Tell me that you're working on these libraries and you'd want me to write some examples if I'm talking all about all these examples. Whatever it is, just feel free to let me know. Yeah. Thanks.